Greetings everyone, Brendan Line, Product Specialist, Exeter Supply Company. The topic for today is going to be controlling water loss in our systems, ways to manage that, and taking a look at a couple different options we may have and develop a plan that works for your utility. There's many different things that we can do to do that, and first things first is we need to understand where we are with our systems and take a look at budgeted funds and maybe some grants and understand maybe there's a better way to help manage a water loss in our systems. So please look forward to the next video, and I hope this helps you guys a little bit. And at the end you will see contact information. Please reach out to us. In addition to this, we do like to come out and do field demos, so if there's something you would like to see hands-on, feel free to reach out to us. So whether it's a ground mic, whether it's correlating loggers, whether it's going to be a real-time correlator or what have you, or even if you have a question about your existing equipment and how you can upgrade that as well. So once again, thank you very much for your time, and we'll see you soon.
Good morning, everyone. My name is Brendan Line with Exeter Supply Company. I'm a product specialist for Exeter. And the topic for this morning is going to be water loss and looking at ways to develop a water loss program to help manage our leaks out in our systems. Some of today's topics are going to look at the water loss program, developing a water loss control program that works for your utility. Water costs money, don't waste it. What's the real cost of lost water? And then we're going to take a look at the theory of leak detection, which will consist of understanding leak noises and how a leak noise is created out in the piping system. So clearly, looking at our current state of affairs, we all have leaks out in the system. We all are dealing with it a different way. As we move forward in life, leak detection is becoming more and more of a topic that is an issue. It's an urgent issue, and every year there's more regulations placed on us, placed on the utilities, which is making it a little bit harder on everybody, and the cost to control our chlorine residuals out in the system and all the chemicals we put in our water. So there's a lot of costs associated with creating clean drinking water in the system. So the better we can manage that, control our water losses, the better we will be as a utility. So we lose about 7 billion gallons of water per day in the US. The amount of water lost in 1 year is enough to supply the 10 largest cities in the US. Lost water accounts for billions of dollars in lost revenue. The amount of NRW for utilities is roughly 10 to 30%. So what is non-revenue water? Well, non-revenue water is clean, treated drinking water that is lost before it reaches the customer. And then what is revenue water? Revenue water is clean, treated drinking water that reaches the customer and generates revenue. So what we see here is our water balance chart. This chart is basically used to do an analysis on our system to see where we are as far as our revenue water versus our non-revenue water. And the big giant yellow box on the bottom that highlights water losses is going to take a look at the two different types of water losses, which are apparent losses and our real losses. So understanding apparent and real losses, looking at our left, apparent losses are customer meter inaccuracies, they're billing system data errors, they're unauthorized consumption. Just know that reducing your apparent losses increases your revenue, but does not recover lost volume. Then over to our right, we have our real losses, which are our physical losses, consisting of leakage, storage overflows, things of that nature. So reducing our real losses recovers volume. Controlling our apparent losses. Unbilled metered consumption. Metered consumption which is unbilled, whatever the reason. This might include water provided to institution free of charge, or metered consumption by the utility itself. Unbilled, unmetered consumption. All authorized consumption which is neither billed or metered. This component includes items such as flushing of mains and sewers, street cleaning, firefighting, frost protection, etc. Unauthorized consumption, again, these are customer stealing service. Establish clearly defined policies to deal with these water service provisions and means to detect common breaches in the supply. This often results in cost being passed along to paying customers. Customer meter inaccuracies. This is a huge one. Meters retain accuracy over long periods of continuous use, but can lose accuracy quickly once they reach a certain age. This may be due to water quality or just the type of meter that you have in the system. So you want to make sure that this is not an issue. Controlling real losses. Responding to reported leaks in systems. Utilities that employ a reactive leak response most likely have excessive leakage that never will be effectively contained. You're constantly chasing leaks out in the system. So controlling leakage effectively requires having a proactive leak management program, means to identify hidden leaks, optimize repair functions, upgrade piping infrastructure as useful life ends. So what's the real cost of lost water? Cost is to produce, you're looking at supply, increased source capacity, additional wells and land. Pumping and equipment are electrical costs or increased maintenance, increased wear, decreased asset lifespan. Our treatment, all your chemicals you're using out there, your monitoring equipment, your soda ash, your caustic, your corrosion control products, your chlorine. There's many different chemicals, and the more water you're losing out in the system, the more water you have to treat, which is going to increase your chemical usage as well, which adds cost. You may have to increase your pipe size. You may have some low pressure issues, some fire protection issues. And customers may need to pay to expand facilities when not necessary. Then we have our sewer system issues, additional pumping and treatment costs. Paying to treat clean water could result in need for additional sewer system capacity. And then we have our repair costs, location, backyard versus street, time of the day, working hours versus overtime, and then outside contractors, and the list goes on and on as far as repair costs go. And then looking at property damage, service interruptions, all these things, again, just keep adding to the value of lost water. So what do we do next? How can we minimize some of these issues? We want to develop a water loss control program. One of the very first things we need to do as a utility is determine our financial impact to utility system revenues. Identify budgeted funds available to address NRW issues. This may also include looking at grant options and just to try to see if there's anything we can get as far as grant goes to help us with these issues, maybe quicker than normal. Develop an effective approach and a action plan for your utility. And basically how we're going to do that is, this is just an example of looking at a 3-step process of how you can do that. Starting with our water audit, like we showed earlier with our water table. Basically just looking at where we are and where do we stand currently. Your intervention then is going to be your action plan, the plan that you develop to try to find leaks out in your system. And you're going to try and do that for say 1 year. And your evaluation step, the third step, would be to take a look at your intervention and see where you're at. Are you happy with your goals? Are there things that you can do differently, more efficiently, more cost effective? And then the process starts all over again with your water audit. And that's a 3-step cycle then on an annual basis. So again, interventions are actions taken by a water system to identify the specific sources of water loss and implement solutions. These actions can include preventive measures such as design standards and effective maintenance. So your reliable construction and design standards allow a water system to maintain maximum structural integrity through its operating life. Effective maintenance is a big one, and this one's very, very hard to stay on top of with all our tasks that we're handed to us on a daily basis. But effective maintenance can help ensure the system operates at optimal performance throughout its lifespan and ensure that repairs are made proactively. Again, meter installation, testing, and replacement. This is a very important thing as well. Meters are our cash registers, essentially. So accurate metering is important for all phases of water audit. Meters record usage and monitor demand, encourage conservation, help detect leaks, and make it possible to charge customers for the water they use. Proper sizing of large meters is very important. Are they capturing high and low flows as they should be? This is something you need to look at, especially on the commercial side. If you have, a warehouse that was used as for example, manufacturing facility, there's 100+ employees there working, using water all day long, all night long. They moved out. Now it's a smaller business that's not using as much water. You may need to look at that meter and make sure you're picking up some of the lower flows as well. So proper sizing, it's very important. Intervention, again, continue on with that, minimizing billing system data errors. So these are going to be errors in our meter readings, errors in our billing reports. Do some customers go unmetered or unbilled? Do all customers exist in the billing system? That's a never-ending battle. Minimize our unauthorized consumption. That's a tough one. Develop some type of plan there to minimize your unauthorized consumption, which is going to be our water theft. Whether it's certain types of meters that can trigger that. Again, that's something that is very difficult for utility to manage. And then we have developed a leakage management program. We want to try to employ a proactive leak management program. Detecting, pinpointing, and repairing leaks generates event data that refines and confirms the water losses identified in the water audit. Pressure management evaluates areas with excessive pressure and implements controls that reduce pressure to cut pressure-sensitive background leakage and reduce rupture rates. And then again, we got to look at our pipe repair and replacement. If we're finding 35 breaks on a 1,000-foot stretch of old cast iron, you may want to take a look at repairing that or replacing that pipe versus repairing. And again, the evaluation phase, were the goals of the intervention met? If not, why not? Where do we need more information? How often should we repeat the audit? Is there other performance indicators we should consider? How do we compare to the last audit? And how can we improve our performance? All right, so let's get into the introduction of leak detection. So I think most of us have seen this. This is basically a chart that will tell us how many gallons of water loss per size of diameter of stream, which is the opening or break in the pipe, along with the pressure in the pipe. And as you can see here, the water the waste per quarter at 60 psi water pressure, and diameter of stream there we have a 1/4 inch, gallons 1,181,500 gallons of water through a 1/4 inch hole with 60 psi, and that's a continuous leak from a hole this size would over a 3-month period. Wastewater in the amounts shown above. So we're going to take that 1/4 inch hole at 60 psi, and we're going to go ahead and add a dollar value to that. And I know what I'm showing here, approximate cost per 1,000 gallons of water is $4, for example. I know this isn't a set figure for everyone. This is just an example. But taking that dollar figure of $4 and adding that into that 1/4 inch opening at 60 psi comes out to approximately $18,904 a year for one tiny 1/4 inch opening on a 60 psi system. So as those holes get larger, or as that pressure gets higher, those numbers can jump down or up either way. So as you can see, a 1/4 inch hole, one single 1/4 inch hole is a big loss. So if we have 10, 20, 30, 40, 50 of those out in our system, could be corpse, could be any type of small little, leak, at a gate valve or something like that, where a pipe's starting to pull away. There's many different ways and parts of the system where there's an unknown abandoned line, or all different situations where we know we have these 1/4 inch opening leaks out there. Here's just an example that we have here. A survey done in June 1st to December 31st back in 2016. These were all proactive leaks, proactive mindset, doing leak detection. There's 53 leaks located, pinpointed and repaired. Accumulated total water loss was 202,728 gallons per day. Accumulated total water loss was 75 million gallons a year. And again, that was using the same format of tracking the size of the break versus the pressure in the system. So the approximate total savings of lost water was roughly $300,000 a year. And again, that's $300,000 per year is a savings every single year. Here's just a case study done up north in Dew Shore in Tioga County, I believe. This was just a demo done during the day. Zero reason to think there was a leak out in the system. It was just kind of a demonstration to show how the tools work. And these loggers ended up picking up the leak. And surely enough, as you can see, the giant red blister spot in the middle of the screen is our leak spot, which is right in the middle of the woods. And this was a lift and shift on the 820 zone scan correlating loggers that we did during the day. So it was pretty surprising for everybody to find that leak in the middle of the woods when they had zero idea there was a leak in the system. So this was very, very beneficial for the customer in this case. But what was important about this was what the operator saw in the system after they went out and found and fixed and repaired the actual pipe. That's what really makes this so exciting. And that's what makes leak detection exciting, is seeing the changes and in a positive way of finding these proactive, finding these unknown leaks out in our system. And when this customer repaired this break, they noticed very, very positive changes for their system. They have 2 wells, and one they basically could have took out of commission completely. It was saving that much water. But looking at it, what the information we received back was estimated over 12 million gallons per year lost resource. It was actually pretty amazing. 48,000 gallons a year, say at $4 per 1,000 gallons. Reduction of approximately 12,000 a year for their electric pumps. Reduction of gas chlorination equipment. They were disinfecting with gas chlorine at each well. So we just figured out very approximate numbers of what that would have been, and it comes out to about $80,000 a year. And the key here is we found a leak proactively, and the savings that you see for that is a forever thing. So that $80,000 a year, or whatever that number would be, is a benefit for you on an annual basis. Here's another example for our friends at East Cocalico Township. They had trouble trying to find a leak. It was not generating a loud leak sound, so it was very difficult for a ground mic to pick this up. But surely enough, with the 820 zone scan correlating loggers using the high frequency ranges that they look for, they were able to find the leak for them rather quickly. And if you look at the report here, you can kind of see, found a possible leak that we knew for several years, but could not pinpoint. And then in the bottom left, the leak estimated about 700 gallons per day. And if you look at the picture on the right-hand side, you can see the pen pointing to the tiny little gap that was shooting water out of it. Very, very, very small leak, not generating a great leak sound in this case. But taking a look at it over a long period of time, they couldn't find this leak, for several years. So if you take a look at that for 10 years, that's over 2 million gallons of water on that one little break. So well done. So understanding leak noise. The sources of noise in the water pipes can include, obviously, our leakage, partial obstruction of pipe bore on our old cast lines and even our ductile lines, consumption, flows or meters, pressure reducing valves, PRVs are big, and our control valves, depending on what time of day they are going to be modulating out in the system, and what time of the day our leak detection is done, whether it's a ground mic during the day or their loggers at night, that can create some noise out in the system. PRVs are probably the most used type of control valve out in our water systems. Partially closed valves, throttle or passing, is very, very common to have a sound generated on a gate valve, per se, that's not closed all the way or it's partially open. Close proximity of the main or sewer pipe. Change in pipe diameter, so if you're reducing from, say, a 12-inch to a 4-inch, that could generate some leak sounds. Electric hum is very, very common and very specific, a matter of fact. So your 60 hertz increment frequency ranges of electric hum. Electric is very consistent and it's all day long, which is what leaks sound like. Leaks are very consistent. They don't come and go away every 10 minutes. But electric, depending on what type of equipment you use, for example, the correlating loggers from Guterman have filters in them because they record the frequency, so they can filter out electric in them, and that way you can have less false leaks in your system. And then music. Teaching rural water classes, I hear customers tell me this stuff, and it just made me laugh, so I had to put that in there. Some guy said, "Hey, I hear music." I'm like, okay, so if you hear AC/DC, you may not want to call the Traco guy up and come out there and start digging up the road. So understanding leak noise and the pipe material, how that affects it. Looking at the list from on the left-hand side from top to bottom, we have our harder materials, our steel, our iron, our copper. Then we get into our AC, our lead and PVC and poly, our plastics. So the good noise propagation is the harder materials, the steel, your iron, your copper. And then as the material gets softer, the sound is less likely to travel at a longer distance on the pipe as steel, iron, and copper would. Here's just a chart looking at some frequency ranges of leaks based off their material. And as you can see, steel, iron, very, very similar. Copper, very high, 1800 hertz. And then again, AC and lead and our plastics are much low hertz leak sounds, frequency range. So some factors affecting leak noise: pipe material, again, hard is good, soft is poor. Pipe diameter, small is good, large is poor. Pressure, it's very important. High is good, low is poor. Background noise can muffle or drown out leak noises, PRVs and throttle valves. Consumption, high levels of consumption can make it hard to hear the leak, and you may have to return at low consumption times. So the best time to perform acoustic leak detection is when all these factors are at a minimum, except for pressure at a maximum. So what we're going to talk about next is how is a leak generated? How is a leak noise generated on a pipe? Basically, what happens is when you have a pressurized environment, for example, say you have an 80 PSI distribution system down Elm Street. Okay, so when there's a break on that pipe and you have a high pressure escaping that break into atmosphere, which is zero, it's the immediate change in pressure from high pressure to zero pressure that actually generates a mechanical vibration on the pipe wall itself, and then that sound travels down the pipe in both directions. Okay, and the distance that sound travels on a stretch of pipe is going to depend on what we just talked about: the type of material, the type of the size of the break, and things of that nature. Backfill can also create some issues. If you have backfill that's able to let the water infiltrate and drain away, that is a positive thing. That's going to help with the leak sound, meaning it will travel much further on a stretch of pipe, versus if you had some type of clay backfill underneath the pipe that was putting back pressure up against that break. That is not as good as a leak sound. And when we have a complete rupture in the pipe, water main break, that when you're having dramatic pressure loss in your system, that generates basically zero sound, which are pretty much inaudible. So again, the smaller ruptures will generate a louder sound. If you can imagine a garden hose just rolling water out of the hose into your yard, basically it's a small gradual drop of pressure until it hits the end of the garden hose. But as soon as you put your thumb over that end of the garden hose, and the more you minimize that opening, the higher the pressure, the further the water will go. So that's just a very simple explanation or example of that. So, and again, that's why proactive leak detection is very important, because you're hopefully finding these leaks when they're newer, when they're smaller, which are easier to find. So the factors affecting good and poor leak noise, again, factors producing good quality leak noise: high water pressure, porous backfill, small ruptures, clean pipes, metallic pipes, and small diameter pipes. Factors producing poor quality leak noise, low water pressure, non-porous backfill, split mains, encrusted pipes, soft or line pipes, and then large diameter pipes. So thank you very much for your time. Hope you understand a little bit more about maybe some ideas to develop a water loss control program. And, just the value of reducing our water losses out in our system. Have a great day.